Hi learners! In today's video, you will learn how a geometric figure is reflected on the coordinate plane. You will also learn how to write the coordinate notation to describe the transformation or the reflection rule that transforms the preimage to the image. In like manner, you will be able to graph or draw the image given the preimage and a description of the transformation to take place on the coordinate plane. Finally, I will walk you through in answering sample problems to let you experience how these are analyzed and solved so that you will be able to successfully solve geometry problems similar to this in the future. If your lesson is on reflection, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us recall what a reflection is. A reflection is a flip across or over an imaginary line known as the line of reflection. After the reflection, the preimage and the image are congruent. That is, the corresponding angles and corresponding sides are preserved. But the image is facing in a different direction. On the illustration, point K on the preimage is facing left, whereas on the image, point K prime is now facing right after the reflection. Thus, we say that orientation is not preserved after a reflection. Do not forget that if the preimage and the image are named using the same set of letters in the English alphabet, like what we have here, the image is the figure with the prime notation. We can represent the reflection that took place with our triangles here this way. Since the preimage is congruent to the image, we can write this congruent statement. Let us have our triangle on the coordinate plane so we can easily discuss about distances. Here, the line of reflection is over or across the y-axis. How do we know that? If we look at the corresponding points L and L prime and check how far is each point from the line of reflection, you will see that the distance is the same. You can count on the grid to check for this. From the y-axis, the line of reflection, to L prime, we count 1, 2, 3, 4, 5, 6, 7. Again, from the y-axis to L, we count 1, 2, 3, 4, 5, 6, 7. The distance from the line of reflection to each point is 7 units. Checking the distance from the line of reflection to point K prime, we have 1, 2. From the line of reflection to K, we have 1, 2. So the same distance as well, 2 units. This is true for all corresponding points. Thus, in reflection, the distance from the line of reflection to a point on the preimage is the same as the distance from the line of reflection to the corresponding point on the image. Do not forget this, learners. You can apply this knowledge in graphing the image after a reflection. Let us now have the coordinates of the vertices of the preimage and the image so we can see how the location changed after the reflection. Recall that a point is represented by this coordinate notation, xy. In 7-3, the coordinates of point L, 7 is the x-coordinate and 3 is the y-coordinate. Let us check what happens to the coordinates of the corresponding points after the reflection. After the reflection, point L prime has now the coordinates -7, 3. Comparing the two coordinates, we see that 7, the x-coordinate on the preimage, is changed to -7 on the image. The y-coordinate did not change. Do you see this, learners? The same thing with h and h prime. The x-coordinate of point H, which is 7, is changed to -7 on the image, but the y-coordinate did not change. Likewise, the x-coordinate of point K, which is 2, is changed to -2 on the image, but the y-coordinate did not change. Our observation tells us that when a point is reflected across the y-axis, the x-coordinate is transformed into its opposite sign, but the y-coordinate remains the same. With that observation, we can write the coordinate notation this way. That is, after the reflection across the y-axis, a point xy on the preimage becomes -xy on the image. The negative indicates a change in the sign. This is the transformation rule for reflection across the y-axis. We can also call this the reflection rule across the y-axis. When a figure is reflected across the x-axis, it looks like this. Here, triangle NFD is reflected across the x-axis to form triangle N prime, F prime, D prime. We will get the coordinates of the corresponding vertices so we can investigate how the coordinates of the image are changed after the reflection. Look at the corresponding coordinates. What do you notice, learners? Right, the y-coordinates are changed but not the x-coordinates. From 7 on point M to -7 on point N prime. From 2 on point F to -2 on point F prime. And from 2 on point D to -2 on point D prime. From here, we can get the coordinate notation for this type of transformation, which is a reflection across the x-axis. Here is our coordinate notation. That is, after the reflection across the x-axis, a point xy of the preimage becomes x-y on the image. The negative indicates a change in sign. This is the transformation rule for the reflection across the x-axis. We can also call this the reflection rule across the x-axis. Let us have the sample problems that follow so we can apply what we have just learned. Sample problem 1. Identify the rigid transformation. Then write the transformation rule that maps the blue figure to the red one. A figure is given. We begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? There are two things that we're looking for here. First, we have to identify the rigid transformation. Second, we are to write the transformation rule that maps the blue figure to the red one. An illustration is given. Now, what do you notice on the illustration? Right, that the image has a different orientation. Another thing is the preimage and the image are congruent, and that the preimage is flipped across the x-axis to form the image. Now, what do your noticings imply? You are correct that reflection took place here. Now, we just have answered the first question. Okay, we move on to the second question, the transformation rule that maps the blue figure to the red one. How do we do this, learners? All we need to do is choose a pair of corresponding points on the illustration. Then get and compare their coordinates. Let us take A and A prime, where A is from the preimage and A prime is from the image. On A, the preimage, the coordinates are -2, 6. On A prime, the image, the coordinates are -2, -6. What changed here, learners? You are correct. The y-coordinate changed. 6 on the preimage is transformed to -6 on the image. In other words, the xy on the preimage is transformed to x -y on the image. Thus, the transformation rule that maps the blue figure to the red one is there you are, learners. We have answered the second question. What are our answers again? The rigid transformation is a reflection across the x-axis is the first answer. And second, the transformation rule that maps the blue figure to the red one is, that is, xy is mapped to x -y after a reflection across the x-axis. There you are, learners. That was easy, right? Let us look at sample problem 2. Here's the problem. Reflect quadrilateral RJLH across the y-axis to form quadrilateral R', J', L', H', then write the transformation rule. Again, the figure is given here. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Again, there are two things that we are looking for here. First, we are to reflect quadrilateral RJLH across the y-axis to form quadrilateral R', J', L', H'. This means that we are to graph the image. Second, we are to write the transformation rule. What are given here, learners? That quadrilateral RJLH is to be reflected across the y-axis to form quadrilateral R', J', L', H'. And the figure is given. Okay, so we are to reflect quadrilateral RJLH across the y-axis to form quadrilateral R', J', L', H'. To reflect the preimage, we reflect the vertices of the preimage one after the other. Let us do this. We begin with point R. We count how far is R from the line of reflection, which is the y-axis. Let's go. 1, 2, 3, 4, 5, 6, 7. Now, from the line of reflection on the same horizontal line where R is, we count 7 units to the right of the y-axis. We count 1, 2, 3, 4, 5, 6, 7. Here is where R' is located. Next, we locate J'. The same thing, count how far is J from the line of reflection. We count 1, 2, 3, 4 towards J. Now, count 4 units from the line of reflection towards the opposite direction. Count 1, 2, 3, 4. Here is where J' is located. Next, we locate L'. The same thing. Count how far is L from the line of reflection. Count 1. Now, we count 1 unit from the line of reflection towards the opposite direction. Then, plot and label point L'. Take note that L', the image, is on the left of the line of reflection. This is because the preimage is located on the right of the line of reflection. Next, we locate point H prime. The same thing, count how far is H from the line of reflection. So we count 1, 2, 3, 4. Now we count 1, 2, 3, 4 units from the line of reflection towards the opposite direction. Then plot and label point H prime. Okay, so all that is needed is to connect the points. We now have the reflected image, quadrilateral R prime, J prime, L prime, H prime. Next, we move on to the second question. Remember that the transformation rule has something to do with the coordinates of the points. Which coordinate was changed after the reflection across the y-axis? To answer this, we have to get the coordinates of a pair. Remember this, learners? Any pair of corresponding points. We will take the coordinates of point J and J prime. Point J from the preimage and point J prime from the image. The coordinates of point J is negative 4, 5. That of J prime is 4, 5. What was changed here, learners? Right, the x-coordinate. The x-coordinate is changed from negative 4 on J to positive 4 on J prime. Thus, the transformation rule is, that is, a point xy on the preimage is transformed to negative xy on the image after a reflection across the y-axis. Remember that the negative in x indicates a change in sign after the transformation. It could be from positive to negative or negative to positive, as in our case here. You can verify the rule by using the coordinates of L and L prime. L being the preimage and L prime the image. You will see that you will get the same reflection rule. What are, again, our answers here, learners? First, the drawing of the reflected quadrilateral R prime, J prime, L prime, H prime. And second, the transformation rule, which is, there you are, learners. We are done with this problem. Let us proceed to our last sample problem. Here's the problem. Reflect R across Y, then across X to produce R prime prime. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Basically, we are asked to get the graph of R prime prime, or sometimes we say R double prime, after R is reflected across Y and then across X. A figure of R is given here. How do we answer the question? Do we understand what is being asked in the problem? How many reflections are to take place here? Right, there are two reflections. First is a reflection across the y-axis producing R prime, and then R prime, the image, will again undergo a reflection across the x-axis to produce R double prime, the final image. Okay, we start by locating the vertices of the image after a first reflection. First, we determine how far the topmost point on the preimage is from the line of reflection, which is the y-axis. So we count 1, 2, 3, 4. Then from the line of reflection, we count going to the opposite direction. We count 1, 2, 3, 4. Here is now the first point on R prime. From the line of reflection, we count towards the second point on the preimage. Count 1, 2, 3, 4, 5, 6. Then from the line of reflection, we count 6 units going to the opposite direction. Here is now the second point on R prime. We do the same thing with the third point. We first determine how far is the preimage point from the line of reflection. So we count 1, 2, 3, 4. Then from the line of reflection, we count going to the opposite direction. We count 1, 2, 3, 4. Here is now the third point on R prime. Next, we connect the points to form the figure R prime. Learners, we are not done yet. We now reflect R prime across the x-axis to form R double prime. Where do you think will R double prime be located after R prime will be reflected? You are correct. It will be on the third quadrant. We will reflect each vertex on R prime across the x-axis, this time to form R double prime. Let's go. We begin with the point nearest the x-axis. By the way, learners, you can begin at any point. From the x-axis to the point on R prime nearest the x-axis, we count 1, 2, 3. So, count 3 units as well from the x-axis going down. Here is the first point on R double prime. Next, we reflect the second point on R prime that is near the x-axis. Count from the x-axis to point R prime. 1, 2, 3, 4. Then from the x-axis, count 4 units going down. So we count 1, 2, 3, 4. Here is the second point on R double prime. Finally, we determine how far is the third point on R prime from the x-axis. So we count 1, 2, 3, 4, 5, 6, 7. Then from the x-axis, count 7 units going down. We count 1, 2, 3, 4, 5, 6, 7. Here is the third point on R double prime. We now connect the points to form R double prime. We have the answer. There you are, learners. We have answered the problem. That was easy, right? One last question before we summarize what we learned today. Had you reflected R across the x-axis to form R prime, followed by a reflection across the y-axis to form R double prime, would the final image be on the same location? Check by doing this. I'm sure you can do it. Okay, let us summarize what we have learned in today's video. We have learned that, first, rigid transformation is a process of moving any two-dimensional geometric figure in space or on a coordinate plane, and reflection is one type of rigid transformation. Second, a reflection is a flip across an imaginary line known as the line of reflection. Third, after a reflection, the preimage and the image are congruent. That is, the corresponding angles and corresponding sides are preserved. Fourth, orientation is not preserved after a reflection. The direction that the image faces is opposite the preimage. Fifth, the coordinate notation for the reflection rules are: first, xy is transformed to x negative y after a reflection across the x-axis. Second, xy is transformed to negative xy after a reflection across the y-axis. Sixth, the graph of the preimage and the image will help determine the coordinate notation to describe the transformation rule that transforms the preimage to the image. Seventh, in reflection, the distance from the line of reflection to a point on the preimage is the same as the distance from the line of reflection to the corresponding point on the image. This concept will help you locate the image after a reflection takes place. Eighth, when solving a problem, you must read it and may read it several times to know what you're looking for, what information are given, and to figure out how the information can help solve the problem. Ninth, when a figure is given, make use of it. It is there to help you in analyzing the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions,